Today we're going to talk about how to use sine, cosine, and tangent to figure out how big an angle is. So let's very quickly review what sine, cosine, and tangent are. Remember that sine, cosine, and tangent are just fractions made from the lengths of the sides of right triangles. So in a right triangle, we label the three sides as opposite, adjacent, and hypotenuse. Adjacent means right next to theta. And remember, theta is just a Greek letter, and it's kind of like x when you're talking about an angle. It just means an unknown angle size. So adjacent means right next to the angle that you're looking at. Opposite means the side far away from that angle. And the hypotenuse is always the side across from the right angle. So if you find the box that makes the right angle, the corner of the box is always pointing to the hypotenuse. Sometimes people get adjacent and hypotenuse mixed up because they're both right next to theta. So it can help if you start by finding the hypotenuse. Look for what is that corner of the box pointed to. That's the hypotenuse. And the other one that's next to theta is adjacent. Now sine, cosine, and tangent, you can remember with SOHCAHTOA. This helps you remember the equations. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. Tangent equals opposite over adjacent. So they're just fractions you get when you divide one side of the triangle by the other. And what this does is it helps us figure out how big an angle is if we know how long two of the sides are. Or in future lessons, it will help us figure out how long one of the sides is if we know another side and how big the angle is. So I'm going to show you something kind of cool about right triangles. So what I have here is I have a right triangle, and you can see that the angle in this right triangle is a 36-degree angle. And up here, I'm looking at the sine of a 36-degree angle, and you can see that I'm figuring out what the sine is by taking the opposite side, which right now is 13.66. I don't know if this is centimeters or inches. It's 13.66 units, and dividing by the hypotenuse, which is 23.24 units, and that gives me a decimal of 0.588. Now what I want you to do is watch this 0.588 as I change the size of the triangle. But as I change the size of the triangle, the thing that's going to stay the same is the 36-degree angle. So you can see the lengths of the sides are changing, but no matter what the lengths of the sides are, now the opposite side is 17.44 and the hypotenuse is 29.66 or 67, but when you divide them, you're still getting 0.588. So no matter how big the triangle is, if there's a 36-degree angle in it, when you divide the opposite side by the hypotenuse, you're always going to get that same number. And it'll be the same for cosine. When you divide the adjacent side by the hypotenuse, I should always get 0.809. And you may be going, well, maybe there's something special about 36 degrees. So let's change the angle. Let's make it 49 degrees. So this should stay 0.656. Okay, well, let's see if it works for tangent. You can see sometimes there's a slight rounding error. This changes from 1.15 to 1.151. That's just because we're rounding some numbers here. But these ratios always stay the same. And so that's why if you've got a calculator, it has these buttons that say sine, cosine, and tangent. Now there's something really important you need to do on your calculator before we go any further. Some of you may have a calculator that has the word up here that says degree, or you may see DEG somewhere on your screen. That's what you want to see. If your screen has the word radian or RAD, you need to change it. And if you don't see anything like this on your screen, we need to check what mode your calculator is. So see if you can find a button that says mode. And on your screen, you should see a line somewhere that says something like radian degree. And you need to go down and set that so that degree is the one that is chosen. And then you can get out of the screen by doing second quit. If you don't have a mode button, you may have a key that says DRG. And if you hit that key, it will change from degrees to radians to gradians. And you want to keep hitting it until you see DEG come up on your screen. Because these are different systems for measuring angles. And if you aren't in the right mode, you'll get the wrong numbers here. Now, most calculators will have keys that say sine, cosine, and tangent. And so right now I want to check that the tangent of 49 degrees is 1.15, and it is. So if you get something different when you type tangent 49, you're probably not in degree mode. We can use this cool fact about right triangles to help us figure out how big the angle is. So if we know how long two of the sides are, what we're going to do is we're going to use what are called inverse functions. If you look at your calculator, you'll see that above the sine, cosine, and tangent keys, it will say sine with a little -1. That's called inverse sine, inverse cosine, and inverse tangent. And those three functions are telling us how big an angle is. So let's explain what these do. So what sine does is it says, okay, you have a 36-degree angle, and I know that if you have a 36-degree angle, if you took the opposite side divided by the hypotenuse, you would get 0.588. So if you type sine of 36 degrees, the calculator will tell you, well, that's going to be 0.588 no matter how long those two sides are. What inverse sine does is it goes the other direction. You're telling the calculator, hey, calculator, when I did opposite divided by hypotenuse, I got 0.588. I want you to tell me how big the angle is. So if you type inverse sine of 0.588, the calculator says, oh, that angle must have been a 36-degree angle. Now, a lot of times you won't bother getting a decimal. You'll just say, hey, calculator, opposite over hypotenuse is 3/5. Tell me how big the angle is. And the calculator will tell you how big the angle is in that triangle. So you've got inverse sine, inverse cosine, and inverse tangent. They all work similarly. If the opposite side is 22 and the hypotenuse is 35, and you type inverse sine of 22 over 35, it will spit out the angle that has that opposite side and that hypotenuse. It will tell you how big an angle is if its opposite side is 22 and its hypotenuse is 35. And similarly with inverse cosine and inverse tangent. If you type inverse cosine of 12/13, it will tell you how big the angle is if the adjacent side is 12 and the hypotenuse is 13. If you type inverse tangent of 25/8, It will tell you how big the angle is if the opposite side is 25 and the adjacent side is 8. So let's look at some steps for the problems we're going to solve. So first of all, you want to figure out which two sides are labeled, which two sides you have numbers for out of opposite, hypotenuse, and adjacent, and label them as opposite, adjacent, and hypotenuse. If you happen to have numbers for all three, great. Just pick your favorite two out of the three numbers. Then you're going to decide whether to use sine, cosine, or tangent. So look at which sides you have labeled. If you know the opposite and the hypotenuse, use sine. If you know adjacent and hypotenuse, use cosine. If you know opposite and adjacent, use tangent. So use SOHCAHTOA to help you remember and to pick which one of those to use. So you write your fraction and then go ahead and use the inverse function of that fraction. So if you know that the sine is 5/13, what you'll type in your calculator is inverse sine of 5/13. Let's go ahead and look at some examples now. This example asks me to label the sides as opposite, adjacent, or hypotenuse, to write an equation involving sine, cosine, or tangent, and then to find the measure of theta. So I am focusing in on this angle down here, and I'm going to label which sides I have. So I always start by looking to see if I've got the hypotenuse. So across from the right angle is 16, that's the hypotenuse. And 10 is right next to my angle, so that's adjacent. So I look at my definitions and look for which one involves hypotenuse and adjacent. So look at that, cosine is adjacent over hypotenuse. Cosine. It might help you to have it written down. You don't have to, but that kind of helps you remember the order. And remember, the middle letter is what's going to go on top of the fraction. So the cosine of theta is going to be the adjacent side, that's 10, divided by the hypotenuse, that's 16. So there's my equation. And now I want to use that to figure out how big theta is. So here's where I'm going to use the inverse function. If I want to know how big theta is, what I'm going to say to my calculator is, hey calculator, the cosine is 10/16. And the way I do that is by typing inverse cosine of 10/16 into my calculator. So on most calculators, the way you're going to do that is you're going to hit the second button and then cosine, and that will bring up inverse cosine, and then 10/16, and then enter. And it tells me, oh, that angle is 51.3 degrees. So you used what you knew about the sides, and you used the cosine, and the calculator was able to tell you how big the angle is. Let's try another example. So this time I'm focusing in on this angle up on top, and I'm looking at the sides. 11 is across from that angle, so 11 is opposite. And 4 is right next to this angle, but it's not across from the right angle, so 4 is adjacent. It's not the hypotenuse, it's adjacent. So I look for which of these involves opposite and adjacent. It's not sine, it's not cosine. TOA, opposite and adjacent. Tangent is opposite and adjacent. TOA. So the tangent, that was a weird looking A, the tangent of theta is the opposite side over the adjacent side. 11/4. Tell me how big the angle is. And the way I'm going to do that is by typing inverse tangent of 11/4 into the calculator. And the calculator tells me the angle is 70.0 degrees. Last example. I'm looking at the top angle right here. 14.5 is opposite that angle. And here's my right angle. It's pointing at the 16, so that's the hypotenuse. So I want the ratio that involves opposite and hypotenuse. That would be sine. So sine equals opposite over hypotenuse. So the sine of theta is opposite 14.5 divided by hypotenuse, which is 16. So theta is the inverse sine of 14.5 over 16. So I'm typing that in. I'm saying, hey, calculator, tell me what angle has a sine of 14.5 over 16. And it says, okay, the angle is 65.0 degrees. So that's how you find how big an angle is if you know two of the sides.